So today we're going to talk about graphs of rational functions. There are some characteristics that we want to talk about first, those being these lines that the graph seems to approach. These are called asymptotes. And when we take a look at asymptotes, there are two in particular. One are vertical. So these guys right here, you're vertical. And you've got your horizontals here. Now, turns out that your vertical asymptotes are limits to your domain. All right, and what that means is that your graph will never equal that value. So in essence, this graph right here skips up and over this asymptote and starts again right here. So since it limits the domain, this is what we call a restricted value right here. Now, in the horizontal asymptote case, these describe end behavior. So what's going to happen to the graph as x goes to infinity and x goes to negative infinity? And as you can see in the two graphs, this has one vertical, one horizontal. This has two verticals, one horizontal. And we also notice that this graph never crosses this asymptote, and it doesn't appear to cross this either, but that's a little deceiving because sometimes it will cross a horizontal asymptote. Again, they describe end behavior, only what happens when x goes to infinity and what goes to negative infinity. So what we're going to do for the rest of the day is we're going to look at a whole bunch of different rational functions and find values for asymptotes, end behaviors, intercepts, etc. And then tomorrow we'll take and learn how to actually graph these things. But today we're going to use our calculator to help us out a little bit. So here we go with our first example. So here I have a rational function, and we want to find our x intercept. So if I find an x intercept, I'm setting y equal to 0. So 0 equals 3x plus 2 over 6x minus 5. Now if I multiply 6x minus 5 to the other side, I basically get 3x plus 2 equals 0. So x equals negative 2/3 is my x intercept. My y-intercept, I set x equal to 0, so I get negative 2/5. To find my domain, I want to find out basically all the real numbers that I can put in here, but in this case it's easier to find out which one that doesn't work, and we know that the denominator can't equal 0. So if I say, well, 6x minus 5 can't equal 0, that's true. And then if I say 5/6 cannot equal x, that's the value of my domain. I can use any other number except for that. Now to find the rest of these, we're going to take a look at a graph. So on this calculator you see the graph of y equals 3x plus 2 over 6x minus 5. You see, obviously we can't really see the asymptotes drawn into here, but you see there is a split in the graph right here, and it appears to be approaching something either way on this side. Now, to find the vertical asymptote, we basically want to know what sets the denominator equal to 0, because that's where it's undefined. If I look at my table, 0.833 repeating yields an error, and 0.833 is this value right here. So the vertical asymptote is actually x equals 5/6. When we talk about end behavior, we want to find out when x gets real big, what is y. So we go back and we look at, I plugged in 3,000 and negative 3,000 to indicate big numbers, x going big positive, x going big negative. And we see that the end behavior, y seems to approach around a half in either direction. And once again, we look at the general graph and we notice we've got some horizontal asymptote, and it turns out it's that actual end behavior. So y equals 1/2 is my horizontal asymptote. this is going to come back into play later. Let's take a look at another example now. Again, we're going to find the x-intercept. If we set y equal to 0, the denominator is always going to go away. So really, to find the x-intercept, it's like setting the numerator equal to 0. So we get x equals -7. We get y equals -7. And our domain, notice the denominator factors. So in this case, if I go x plus 1, x minus 1, not equal to 0, we get x not equal to -1, x not equal to +1. And I'm going to make a guess that I'm going to get vertical asymptotes on this before I even look at my graph of x equals -1 and +1. Don't know what the end behavior is going to be yet, but we'll find that out in a second. So if I look at my graph of this function, you'll see that I have two kind of asymptotes right here where this graph seems to pick up and then move over down to this area right here, and then it picks up again and goes up to this area up here. We want to know where those are, so if we look at a table of this graph, and I plugged in 1 and -1, notice we get errors, so our domain is limited there, and those are my vertical asymptotes. To look at the end behavior, I plug in 3,000 and -3,000. That's pretty far to the left and the right. And you'll notice I get a scientific notation of -3 times 10 to the -4th, which is basically 0 in both cases. So in this case, my y value is going to 0, so thus my horizontal asymptote is y equals 0. And again, let's take a look at the graph. And we see in that graph that this function appears to be getting really, really close to 0 as x goes to infinity into -infinity. And then again, we'll pick this up in the end because we're going to try to find out, kind of know how we're going to find vertical asymptotes by finding the domain and setting the denominator equal to 0. But how are we going to determine these horizontal asymptotes? And we'll look at all three examples in the end to figure that out. So let's move on to our next example. So once again, we're going to find our x-intercept by setting our numerator pretty much equal to 0. And I have to factor in this case, so that's 5x squared plus 2x minus 7 equals 0. I'm going to need a 5x and an x, and I'm going to need a 7 and a 1. This guy's got to be my positive, this guy's my negative, so I get -7/5. And 1 is my x-intercepts, my y-intercept is 7/5. My domain is going to be determined by looking when that denominator is equal to 0, so x squared minus 4x minus 5, that can equal to 0. I factor once again, and I get 5 and -1, and that's what x cannot equal. Vertical asymptotes, I'm going to guess, are going to be at -1 and 5. End behavior, not so sure, but we'll check on the graph right now. So I look at the graph, and you'll notice this is a little different graph than last time. It's moving down and picking up, coming up here, moving down kind of like a cubic, picking up again, and then coming up here. You'll notice the graph kind of hits the x-axis somewhere around almost -2, not quite, and that's -7/5. Over at 1, it goes through again. And you'll notice these appear to be leveling out a little bit higher than in the last problem. So now let's take a look at our table. You'll notice once again that in our table at -1 and 5 we get errors. So that means the graph is undefined there, so that did describe my vertical asymptotes. And as I plug in -3,000 and 3,000, you'll see that this is getting very, very close to 5. So that's going to be our horizontal asymptote. And again, right now we're just getting these horizontal asymptotes off the graph. We'll tie this all together in a couple of minutes. So let's take a look at one more example. So once again, we're going to take and find our X Intercept, setting the numerator equal to 0, which is going to be X equals 0 basically. Y Intercept, it's also going to be 0. Domain, denominator cannot equal 0, so that's 2. Whoops. X cannot equal 2. I'm going to guess my vertical asymptote is X equals 2. End behavior don't know, so let's take a look at the graph. You'll notice this graph's kind of weird. It moves down, picks up, comes back up here. It looks to be right around 2, but we'll check that in our table. But you'll notice in this case, these don't appear to have a leveling out portion of the graph. This appears to rise forever, and this appears to go down forever. So we'll have to look at our end behavior to do that. So let's go to the table. You'll notice when I plug in 2, I get an error, so that is my vertical asymptote. When I plug in very big numbers, 3,000, negative 3,000, you'll notice that I get very big numbers. 1,200 here, negative 1,199 here, so almost negative 1,200. They aren't going to the same number. In fact, they're getting bigger and bigger as I go away. So this has end behaviors of y going to positive infinity and y going to negative infinity. So again, this really has no end behavior. Or rather than no end behavior, as x goes to infinity, y went to infinity, x goes to negative infinity, y goes to negative infinity. So there is an end behavior, but it doesn't approach one number, if you will. So there's no horizontal. Asymptote. All right. Now what we're going to do is we're going to take a look at all of our functions and then what was the case in each as far as horizontal asymptotes went. We said that in this case there was no horizontal asymptote, and if we look at our function, okay, we don't see a big relationship here. If we go back to the previous function, we notice we had y equals 5 as our horizontal asymptote, and we look here, and then we go back to here, we had y equals 0 as our horizontal asymptote, and we go here, and y equals 1/2 was our horizontal asymptote. Well, to ruin the secret, basically what we're going to do is we're going to look at the highest degree terms in each case. Notice, if I look at the highest degree terms, I have 3 over 6 as my coefficients with my highest degree terms, and 3 over 6 happens to be my horizontal asymptote. Likewise, in this third example, highest degree terms, they match. 5 and 1 are my coefficients, horizontal asymptote 5. Now, in the other cases we had, notice highest degree terms, these didn't match. In my last guy, once again, highest degree terms didn't match. So there are some rules for horizontal asymptotes. Here they are. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is going to be y equals 0. That was very much like this guy right here. Degree of the numerator was less than the degree of the denominator, horizontal asymptote y equals 0. If the degree of the numerator equals the degree of the denominator, the horizontal asymptote is equal to the division of the leading coefficients. So that's like our first example, leading coefficients 3 and 6, horizontal asymptote 1/2, and leading coefficients 5 and 1, horizontal asymptote 5. Lastly, degree of the numerator is equal to degree of the denominator plus 1. There's no horizontal asymptote. In fact, something called a slant asymptote exists, and we're going to deal with that tomorrow, and I'll show you how to find that. But today is not the day for that. So anyways, those are your 3 rules. Be good to know those. Next, We're going to state the domain, find the intercepts, and find the asymptotes. So we should be able to do that. The domain is going to be found by taking and factoring the denominator, setting it equal to 0. So I've got x minus 7, x plus 1. So I get 7 and negative 1. X is not equal to those. Intercepts, again, set the numerator to 0. X plus 3, x plus 2, so negative 2 and negative 3 are x-intercepts. Y-intercept is just 6/7 of the negative type. Horizontal asymptotes, or let's do vertical first. The vertical asymptotes, we get these from our domain, so that's x equals 7 and negative 1. Horizontal asymptotes, take a look at the degrees. Notice they match. Leading coefficients, divide those. Y is equal to 1 is going to do that. Let's take a look at the next example. We'll go through a few of these. So again, state the domain. I'm going to have to factor this guy, which is not going to be pretty. So x cubed minus 8. And I go through and do that, I get x minus 2, x squared plus 2x minus, actually that's plus 4, sorry. When I find this guy, I get 2. This is going to have to be put into a quadratic, right? So I've got negative 2 plus or minus square root of 4 minus 4 times 1 times 4. Problem, this gets an I term. Nothing here. So my x-intercept, I'm sorry, this is my domain. X is not equal to 2. Vertical asymptotes. Again, x equals 2 because that limits my domain. Horizontals. Notice the degrees. Power bigger on bottom than on top. So in that case, I get y equals 0. I've now got to take and find my intercepts. So in this case, I'm going to basically factor the numerator. That's 5x. X. Need a 2 and a 1. Plus here, minus here. I get 2/5, negative 1. Y-intercept, I get a quarter. Keep on moving. In this case, again, we can find the domain. X not equal to 1. That's going to give me my vertical asymptote. That's going to be a negative. X equals negative 1. Horizontal, degree of the numerator greater than degree of the denominator. There's none. X-intercept, factor, I get negative 7 and 2. And then the y-intercept, basically we're just going to set that equal to 0 and I get negative 14. Alright? One last example. So this is all in factored form, however I can do a little mental math in here. I'm going to have a 6x squared as my numerator and an x squared as my denominator. As far as highest degree terms go, when I FOIL that out, if I want my domain, then basically I'm setting the denominator equal to 0, factoring and solving, so negative 2 and 1 X cannot equal. The verticals are going to be X equals -2 and 1. My horizontal, as I stated before, my degrees match, so I take my leading coefficients of 6 and 1, divide those, so y equals 6 is my horizontal. X intercept, set the numerator equal to 0, so I get -7/3 and -1/2. My y intercept, basically just set x equal to 0. In doing so, I get 7 on top, and on the bottom I get -2. Alright? That's basically all you're going to be responsible for today. Tomorrow we're actually going to put this all together and graph these. Alright, so good luck with the homework, and on Monday you'll get another one of these videos, and I'll be back Tuesday, and we'll probably have a review day and we'll wrap it all up. Okay? See ya.